Broadcast is now starting. All attendees are in listen-only mode.
Hi, good morning. Welcome to Ironside's Take 30. This week is Take 30 with a data scientist. I'm Pam Asgar. I'm the Director of Data Science at Ironside, and I'm joined today by Jonathan Tao from Snowflake. We are going to be talking today about how Snowflake can empower your data science team. And Jonathan will be back in 2 weeks from today. You'll see the agenda there on the 24th to talk about Snowflake best practices with our data advisor. So going to jump right in here. Ironside's a data and analytics consulting firm. Our mission is to help our clients use data to make better decisions about their business. And we do that with over 20 years of end-to-end data and analytics expertise. We have centers of excellence in every capability you see here on the wheel, from advising and strategy to design to building, where a lot of the data science work lives, deployment, governing, and managing long-term. So that's a bit about us. Today, what we want to talk about is data science process, really the work that you do before you get to the machine learning work, and how the traditional approach creates some challenges that cloud feature stores, specifically Snowflake, are really great at coming in and helping us out with. So then I'll turn it over to JT to talk about Snowflake, what it is, and how it helps with data science. I want to start with this quote from Uber that says, "Data is the hardest part of machine learning, and it's the most important piece to get right. Modelers spend most of their time selecting and transforming features at training time and then building pipelines to deliver those features to production models. Broken data is the most common cause of broken problems in production machine learning systems." And it's very true that the majority of our time is spent gathering data from various sources, massaging it, getting it to work right together, and then preparing it to be ready for machine learning. And what that looks like in kind of the traditional approach is to build a pipeline of your features in isolation from other use cases. So you work on one use case at a time, and that's really all we think about. And data science, as I said in other sessions, is very iterative in nature. And I presented these couple of slides in a prior session on feature stores. So I'm going to use this to demonstrate that same concept. If you look here at model A, this is a data pipeline creating 3 features. I just use shapes to demonstrate those. Let's say later we come in and we build, we have another use case and we build another pipeline. We may use the same features over and over again because they may be relevant to different use cases, but they're always built in isolation from one another. And what that does is it ends up creating a lot of technical debt. There's redundancy there because you're creating the same thing over and over again. And then there's no ground truth. Different people code things different ways. You code the same thing this year differently than you might have last year, and so that you don't have that ground truth. And your features are really embedded in these pipelines. It's not like you can go back out and pluck them out. They're really built in that iterative, exploratory way that data science is done. And Google called machine learning the high interest credit card of technical debt. And it's very true. And so the newer approach to this is called feature stores. And once you learn about feature stores, you kind of wonder, well, that makes sense. Why hasn't data science always done it that way? But it is a fairly new concept. It was introduced by Uber. And the idea is, instead of just pulling your data and iterating through features in that exploratory way, we think about what are the different topics that we're going to create, and we create a data warehouse with those in mind. And so we might have some features about customers, and so we're going to have a customer table and customer products, and we're going to have those, and we save these scripts kind of individually so that we can use them and pluck them out as we need for model A or later for model B, where we might want also some customer features and some claim features. And the problem is that when you try to do this in an on-prem database, you incur even more technical debt. You have the ability to reuse these features over and over, but the issue now is that I'll say iterative and exploratory so many times today, but that's what data science is. And so this feature store, this data warehouse that you want to build, it has to grow and shrink. It has to be scalable and flexible. You don't want to buy a huge chunk of space that you're not going to use for a couple of years, and you don't want to limit yourself when you need to scale and expand. And so that's where Snowflake has been very valuable for us. It's been our choice for our data science as a service platform, and it's also incredibly helpful to bring in third-party data and store that in the same place, to share our data back to our clients so that they can have access to the feature store to bring their data in and out. So the unlimited storage, elastic compute, and other benefits have been incredibly valuable to empowering us as data scientists and kind of breaking some of the chains of tying us down to an inflexible database. So with that, I'm going to turn this over to JT to kind of go through really what Snowflake is and their approach to data science. Go ahead, JT.
Great. Hi, everyone. I'm JT. I'm a partner sales engineer at Snowflake. And so, before I really get into describing and introducing Snowflake to you guys, let's take a look at what we're seeing in our prospects and what we're seeing across industries at what companies do want in their cloud data solution, right? So, pretty standard asks for the technology, right? They want something that is going to allow them to make better, quicker business decisions, all while reducing the cost of scaling the necessary technologies to make that happen, right? And the technology that they're going to choose has to be something that's going to be a great customer experience, also a great experience for those responsible for managing that solution. Next slide. So, why do we choose the phrase cloud data platform, right? Phrases or terminologies you're probably familiar with, is enterprise data warehouse, maybe Hadoop or, some sort of data store, data lake, right? And really we see the evolution as such, coming from on-prem data warehouses, having that almost pivot away, the swinging pendulum towards data lakes and Hadoop as people started to realize the value of data and have access to more and more data. But then that caused its own sort of set of issues and problems around scale and access to, insights on that vast amount of data. Yes, you could get the data onto the platform, but then gaining those insights was difficult. And then that's kind of what led to the evolution of the cloud data platform that Snowflake falls under, right? It's the ability to get your hands around, all sorts of data in a way that's completely scalable, not only from a storage perspective, but from a compute perspective. So no longer are you limited on either end, right, of these resources to provide insights to your consumers. Next slide, please. So again, when we look at prospects or customers that have a data strategy, we typically see this type of issue. And I want to put this on the screen because it's going to help contextualize exactly where Snowflake as a cloud data platform is able to solve and what workloads and sort of tasks that go into your data landscape, where Snowflake's going to be able to fall into place. And really, that transformation and manipulation of data from the left to the right can be a very complex web of paths and copies of the data and different technologies touching the data. As you can see, data warehouses being in that third column from the left is just one piece of the puzzle that exists in mature data implementations that we see today. So next slide, please. So after seeing that, Snowflake is truly a cloud-native cloud data platform able to solve all these data workloads that we see as being very vital to enriching and transforming data and making it available to all the data consumers that might exist on the platform, right? So you might think to yourself, well, okay, well, I thought Snowflake was, like a Take30 or like an Oracle in the cloud, it's a data warehouse. Data warehousing is one of our core competencies, but it's really one of the 6 primary workloads that Snowflake is really good at solving. That's why we don't call ourselves a cloud data warehouse, but a cloud data platform. And actually in today's discussion, I really want to talk about how Snowflake handles data science, because that's relevant to what we're talking about today. And the ways that Snowflake's going to be able to accelerate machine learning and artificial intelligence for your end users. Next slide, please. So before I get into that, it's important to kind of understand, the high-level architecture of Snowflake is really kind of broken down into 3 primary tiers. We're going to start at the center, which is the centralized storage, right? So this is simply using the the object store of the cloud that Snowflake is going to be deployed on for you. And this is, of course, instantly scalable. There's no management that you have to do to provision space before just loading the data onto the platform. The next tier is the multi-cluster compute. It's important to note that this is a completely separate tier, thus providing a complete separation of storage and compute that's going to allow both of these tenants to scale independently and instantaneously from each other. This idea that each one of these slices of that band in that second tier is actually separate from each other hints towards this ability to have workload isolation on Snowflake. And so this idea where data loading, BI, data science, all these type of workloads can actually have their own independent compute working on the same copy of the data in a way that won't interfere with the resources of any other workload. And then that last band is what we call the scale out or compute or cloud services. And really it's going to be the brains of the technology, the brains of Snowflake. It's going to allow Snowflake to behave a lot like that enterprise data warehouse that you've known and love and come to become really good at, while providing it in this instantly scalable package and experience. And a lot of the unique Snowflake technology and features that we have are orchestrated through the metadata management that this layer can perform. Now, this whole experience, this whole technology is as a service solution. So technically, there is another tier. I don't really count it as a tier, but it's really the foundation of providing this architecture on the cloud agnostic layer. We are available in GA in the 3 major clouds that you see there below. And we do have this cloud agnostic sort of behavior and characteristic where interactivity and data sharing across clouds on the Snowflake technology is entirely possible. And it's really, when you think about strategies around not being vendor locked into a single cloud provider, Snowflake is a very unique technology as it's able to do that and achieve that goal. Next slide, please. Cool. So, and feel free to click through this pan just to get all the visualizations up. Just to give you an idea of the different types of workloads that can happen at the same time. I hinted at this a little bit on the last slide. Whether it's loading, batch loading, streaming loading that we have built-in tools for. All these, again, can be run simultaneously with consumption, whether it's data science, BI workloads, and just, within each of these workloads, I am providing a couple of different tech partners that we work really closely with and are, great integrations that we have for the Snowflake technology. Okay, next slide, please. So how does Snowflake, really, lend itself to accelerating data science and being a perfect tool for this workload, right? Some of the things, that I was talking about that, around the separate storage and compute and instantly scalable workloads, obviously that makes a lot of sense in that capability. The ability to, again, bring any data set. One feature that I'm not going to focus too much on, but I think is very important specifically for the data science workload, is our idea of using the data marketplace and our underlying feature set of data sharing to instantaneously sort of enrich your data sets in a way that requires no ETL, right? Data sharing is this ability for any Snowflake account to any other Snowflake account to immediately, securely, and instantaneously share data between them. Taking a look at data engineering, obviously that's a huge part in preparing data and massaging data required for data science. And we have great integrations with existing sort of manipulation tool sets and technologies and languages around that. So whether you do that, with SQL, right, in a very ELT format, or you can obviously leverage different language or different drivers to also manipulate the data, that's totally supported on Snowflake as well. And of course, at the end, on the consumption end, right, we saw a little bit of exactly the technologies and tech partners that we do have for machine learning and AI. And again, those connectors for languages are also supported so that you can write in your favorite language and query Snowflake directly to access the data. Next slide, please. So, and I think clicking through 3 times to get the text, yeah, a little bit of an eye chart, but really the takeaway on this slide is, the importance of, evolving your data science approach and data science efforts, and really what scales directly with the value of data science is the ability to get your hands around and wrangle more of your data, right? The more data you have to inform the algorithms, inform the training models of whatever you're running, is going to allow you to create more accurate, more insightful conclusions on your data, and really that's the name of the game. And that kind of really jives right with the features that I have been talking about that are very specific to Snowflake. The data sharing, data exchange, instantly scalable storage and compute that's separate from each other, right? All that jives with this kind of value curve and goal for growing and maturing data science initiative at your company. Next slide, please. Okay, so yeah, I really want to, again, highlight a little bit the data sharing feature, right? And key in on exactly, how important and valuable it is to have no data movement and no ETL when bringing on new data sets, right? The data is live and secure. So from the data source, whoever is, providing that data to you, as they update that, you're going to see those updates instantaneously. The data provider also has a very secure and controlled way to determine and establish who exactly is able to see their data, right? And this is established through, tried and true RBAC, role-based access control methodologies that have been industry standard for decades. And then, from the data consumer side, right, the value is all there. Next slide, please. And the easiest way to kind of show, how transformative this is to compare it to the approaches that are, the standard approaches to data sharing that exist today, right? When you think about ingesting a different data set into your data environment, it typically involves one of these approaches, whether it's downloading data from an FTP, grabbing it from a cloud storage object store like S3. Maybe it's shared on, via compressed CSV, Dropbox, Box, some sort of zip file that way. Or maybe it's a little bit more advanced. Maybe the data provider has given you an API endpoint to pull down data, which will give you access to maybe more recent data that the data provider has. The real takeaway here, right, is really that top row. Does not require ETL. Snowflake Secure Data Sharing is really the only approach that does not require ETL. Any other approach is going to require you to manipulate, transform, and bring that data into your data environment in a way that takes time, causes the data to become stale, and really kind of reduces the value of it, as opposed to having it instantly available in your Snowflake environment. So if you only remember one line from this chart, it's that top one. Next slide, please. Right, and so the data marketplace, I've been using data sharing, data marketplace kind of interchangeably so far. Data marketplace is really this evolution of data sharing in a way that's, very one-to-many in a sort of publicized, marketplace, if you use the same word, where you can come and bring data into your environment and see exactly what is publicly available to you, at the click of a button. And these data sets can be, free to access, standard, or they can be personalized data sets. So personalized data sets are ones that are specifically tuned and curated for you, the data consumer, and are often monetized by the data provider. So on the flip side of this is an entirely different opportunity for data providers to monetize, run their entire business if it's around providing data through the Snowflake data marketplace as it literally reaches the eyes of over 4,000 customers today. Next slide, please. So, in conclusion, right, when we're taking a look at running Snowflake and having a data science workload on it, really the three pillars of why this is going to be a great choice is, again, that consolidated source for all data and ability to, really define all data at the moment's notice, right? Whether it's with data sharing, being able to bring in data through different means in a way that's completely scalable is really important to driving a valuable data science effort. Efficient data preparation, right? Whether you're, again, going to transform in an ELT SQL style, use maybe a Spark or Kafka connector or some other transformative language, we support that as well. Again, in that instantly scalable manner to not affect any other workloads. And of course, we're constantly building and working with tech partners in the ML AI space to provide that rich experience using the best in breed tools that exist today in the marketplace to, again, provide a very feature rich and modern data stack. And that's really the name of the game. Next slide, please. Right, so the key takeaways overall, right, taking a look at, addressing technical debt caused by data access, ingestion, and manipulation of the data. Snowflake's really going to be able to come in and address that problem for you. When we look at Snowflake as a cloud data platform, focusing on data warehousing, data science, and data engineering, even as well as data sharing, right, are really going to help drive any sort of ML AI efforts. And those are all core competencies of the Snowflake platform. When we look at specific features and attributes of Snowflake, the separation of storage compute, I mentioned that a bunch, is really a key takeaway. Having that workload isolation, being able to run transformations, being able to run data science workloads completely separate from anything else going on the platform is really revolutionary. And then lastly, right, that data sharing piece, right? Being able to, at a moment's notice, bring on and transform your data sets is what's going to allow you to evolve data science in a way that is going to scale and ramp much faster than any other approach out there on the market. Cool.
Thank you, JT. That's really helpful. And I just wanted to add too that I can certainly attest to the value and the ease of use of Snowflake in the data science work. And also I wanted to mention the marketplace and how it's very cool to go in there and kind of shop, for data sets and very easily bring in some third-party data, because with data science, again, it's iterative. So it's hard to go through a ton of work to bring in data and do all the work to acquire it and bring it into your environment just to find out it's not really that helpful. So it's been so nice to be able to speed that up, bring data in, see how it could add some value, and move on with it. So it's been a great tool for us at Ironside. I wanted to now turn it over to the audience and open up for questions. Debbie will allow you to take yourself off mute, or you can type them up in the chat box, and JT or I can take any questions you have on data science with Snowflake. There's a question about the feature repository in data engineering. So if that's about the feature store for yeah, feature repository is perfectly fine word too. For data science, the idea there is to really build a place to store all the features that you're building. And your features, maybe I should have backed up, and these are the attributes, the predictors, the fields that are driving the power of a machine learning algorithm. It's what you think is correlated to whatever it is you're trying to predict. And there's a lot of work to acquire those, to prepare them, and to tweak them so that they're appropriate for machine learning. So there's a lot of work that goes into that. So doing that and then storing it and governing it allows you to come back when you have another use case that, hey, I'd like to use that same customer data or claims features, and they're already prepared and sitting there, and you have the associated queries for those, and so you can just reuse them later without having to acquire all that technical debt of redundancy and lack of ground truth. I hope that answers that question. Let me look at the others. So JT, what are the partner technologies available via Partner Connect as part of the data preparation?
Yeah, so Partner Connect, I can look right now. So I guess let me back out. So Partner Connect is really the built-in sort of, couple clicks integrations that we have within the Snowflake UI to get started with, data science, ETL, BI. It varies on the data stack where these tools are. Now, that's not to say that if a tech partner is not on the Partner Connect, that we don't have a connector for it. This is a very specific sort of very low barrier to entry integration methodology that we're trying to grow over time. But when you think specifically on data science, the ability to connect to Zeppel, Sigma, looking at the list here, Data Robot are some of the ones that we have available on Partner Connect. However, we do have great integrations with AWS SageMaker and Data IQ, to name a couple, H2O AI, that while they're not on the Partner Connect, we definitely have tight integrations, and those would be a great partner with Snowflake in your data stack.
Thank you. A couple other questions for you. If you want to share data, does the recipient also need Snowflake?
Oh, great question. So the answer is no. You can technically share data with a reader account. And really the reader account will allow the data consumer to consume the data. It's kind of a dummy version of Snowflake that they will get. It would still be able to run SQL, connect to any type of tool that they have on their end. They just won't be able to manipulate the data in any way. And then, of course, the data provider in that case would assume the cost of the reader account as they consume the data, as opposed to the Snowflake methodology, where the data consumer would use their own Snowflake's resources and credits to consume the data.
Okay, that's a great question. It sounds a little long. I'm going to read through it. As this is a pay-per-use premium, do you have any existing systems set up to monitor and predict the duration of model run, anticipating its length? Goes on a little bit. As a data scientist, one of the main concerns is that we'll develop an innovative model, but if one of the hyperparameters is off and a model is running for a long time, we as a consumer will be responsible for that cost. So do you have anything to prevent those kind of situations?
Okay, good question. So, I mean, there's nothing really to, I would say, evaluate an effort, a data science effort or workload. But there are ways on the Snowflake platform to control and monitor costs, whether you're going to leverage resource monitors to monitor credit consumption, controlling the type of size and shape of the virtual warehouse that you're running these workloads on. These are important things to recognize and put into place to, again, kind of put a barrier around exactly that, runaway credit consumption. So just best practices to start small, scale up from there, right? We respect linear scalability because each of our warehouses is sized in doubling sort of resources. So, just being mindful of that approach and using the tools at your disposal to control that.
Great, thank you. That's another good question. Thanks, JT. I want to thank you for joining. We're at the top of the hour, and I don't see other questions coming in, but feel free to reach out to us by email. I also just wanted to mention next week, we have a special event. We have our Take30 on Thursday at 10, but at 11, we have a special event we're hosting with IBM about cybersecurity. So you can go to our website to learn more about that and register if you're interested. All right. Thank you, everyone. Thank you for joining, and have a great week.
Thanks, everyone.